let's look at the Cori cycle. Now, the Cori cycle is also known as what? The lactic acid cycle. So if you don't call it the Cori cycle, you call it the lactic acid cycle. And it was discovered by husband and wife, Getty Cori and Ferdinand Cori. So that should be a motivation. Alright, so now in the Cori cycle, we are looking at the end product of glycolysis. We know is pyruvate, right? But if oxygen is not present, that pyruvate cannot undergo oxidative decarboxylation to form acetyl-CoA. Instead, the pyruvate will be reduced to what? Lactate. Good. And the lactate can accumulate in the muscles. So in the Cori cycle, we are looking at how the lactate formed from anaerobic glycolysis in the muscles is transported through the blood to the liver and converted back to glucose. Now let's start with this. This is the glucose. From your bloodstream, it is transported to your liver. The glucose, now after digestion, the glucose is in your liver now. From the liver, this is the glucose, same glucose in your blood. This is the one transported to your muscles. Now the glucose in your muscles can undergo glycolysis to form what? 2 molecules of pyruvate, right? Remember the end product of glycolysis was 2 molecules of pyruvate, is it not? 2 molecules of pyruvate, and we release 2 molecules of ATP, right? 2 molecules of NADH was also released in the process, was it not? Now this was our end product of glycolysis. This pyruvate now, since oxygen is not present, it cannot be converted to acetyl-CoA. Instead, it is reduced to what? Lactate. And remember, in reduction, the reducing agent will be oxidized in the process, right? So NADH is converted to NAD+. So here we are even utilizing NADH. Do you get that? So now this is the lactate in your muscles now. The lactate is now in your muscles. Are you feeling this in your muscles? Okay, it's in your muscles now. Now, in the muscle, the lactate, the 2 molecules of lactate is transported to the blood. This is your blood now. And from the blood, it is transported back to where? The liver. And in the liver, the 2 molecules of lactate is oxidized to what? 2 molecules of what? Of pyruvate. Now, there's something I didn't put here. 2 molecules, if lactate is oxidized to pyruvate, what do you think will happen? What are we producing? NADH will be produced, right? From NAD+. Now, 2 molecules of lactate is oxidized to 2 molecules of pyruvate. And you agree with me that pyruvate can follow the gluconeogenetic pathway, gluconeogenesis, to form glucose, right? So it can follow gluconeogenesis to form glucose. The glucose can still be transported back to the muscles when you do exercise or strenuous activity, and oxygen is less. It's converted to lactate to be transported to the blood, to the liver, follow gluconeogenesis, form glucose again, and the pathway continues. Is it not? Now, if you look at this, take note of this important stuff here. If you can check this, we utilized 6 molecules of ATP in the gluconeogenetic arm of this pathway. We used 6 molecules of ATP. How many did we produce here? 2 molecules of ATP, right? So generally in the Cori cycle, did we produce ATP or we use ATP? We used ATP, right? Because here we are producing 2 and here we are using what? 6. So how many molecules of ATP did we use? We used 4 molecules of ATP in the Cori cycle. So basically, this is what the Cori cycle is all about.